Hello, this is Year 1 Core Maths Red Excel 14.5 Laws of Logarithms. So our laws for logarithms are here. You need to know, understand and learn these. They're not in your formula books and they're really, really key. They come up as a question in itself. Sometimes logarithms can. They equally come up within a problem. So you may find that you're doing a question that's of a problem type format, and somewhere in there you'll need to use your log rules to help you move on to the next stage. So key to learn. So let's go through them one at a time. Starting with this one, this is called the multiplication law. What you'll notice is you have two logs which have the same base, and however the value that you're logging to that base is different. And when that's so, we say the log of x to base a plus the log of y to base a is equal to the log of xy to base a. So the x and the y have multiplied to join together to make the new expression. Now, looking at that there, you're going to say to me, hopefully, or question why. So I'm going to go on to the next slide and explain why. So here, what you'll notice is I have two logs, the bases are the same and they're adding. Now, you need to have firmly in your head that log to the base 2 of 4 is actually equivalent to. And that came in the previous section, and you should be quite fluent and confident. If you're not, go back and look at that. You should also know that the log to the base 2 of 8 is 3, because the answer to both of these is what the exponent is. Because that's the whole point of logs, is finding out what the exponent is. It's a different way of writing an exponential function because of that link. Now, let's just say we're saying from the rule that was on the previous page that if you multiply x and y together, that's the same as this. So let's go for that. So we're going to multiply together the 4 and the 8. So that's log to the base 2, and 4 times 8 is 32, because remember we're multiplying the 4 and the 8. So if we go back to this idea of the exponent, we want to know what power do we raise 2 by to get 32, because if 2 is our base, what's the power, or what's the exponent? I raised 2 to get 32. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it's 5. So my answer is 5. And if we look, that's correct. 2 add 3 does equal 5. So what I've done here, just to go back through this, is I've written it out as a logarithm using the multiplication law here. And here I've written it out with the actual answer of this log of 4 to the base 2, log of 8 to the base 2, and then I've calculated what log of 32 to the base 2 is, and it does work. So going back, that's our first rule. The second rule here is about division. And again, I can go back and I can show you this with the example above. So let's do log to the base 2 of 8, subtract log to the base 2 of 4. Well, we say that when we subtract, if we just go back here, when we're subtracting with the same bases, then it is here the x divided by the y. So moving on there, that would be the 8 divided by the 4. So that's log to the base 2 of 2. So putting this in number form, log to the base 2 of 8 is 3. Take away log to the base 2 of 4 is 2, because we already know that. And this here, if I just put an extra line of working in, this is log to the base 2 of 2. Well, log to the base 2 of 2 is 1. Because what power do I raise 2 by to get 2? I raise it to the power of 1. And this works. So actually, I've just shown for that particular example, remember that's not a proof. All I'm doing is giving you an example to show you how it works. Okay, so that's that one. So when we add two logs of the same bases, then we can multiply x and y. When we subtract two logs of the same bases, we can we divide x by y. And the last one, I'm going to write here log to the base 2 of 2 cubed. Okay? And what we're saying is that is the same as 3 log to the base 2 of 2. Now, if you're just going back to that, here we're saying if you've got something to the power, then the power or the exponent, better still the exponent, you can multiply at the front. So here's my power or my exponent, and I'm multiplying it at the front. So I just highlight those so you can see what's happened. Now log to the base 2 of 2, well that's 1. So this would become 3 times 1, which equals 3. Well, if you're saying, well, I just want a bit more proof, well, log to the base 2 of 2 cubed is log to the base 2 of 8. Well, what is the exponent for 2? To get 8, well, it's 2 cubed, so we also know that that equals 3. So these are the same, and we can say if these are the same and that's 3, and we've then multiplied by our exponent here, and log to the base 2 of 2 is 1, then you can see I have managed to get the same answer both ways. You will not be expected to come up with this, but the reason I've put it here, by the way, is because people go, why? Now, if you're still not sure, you need to ask again or watch the video again, because some people are desperate to understand the why, and other people are quite actually happy to take on that these rules do work. The key thing is that you use them, you learn them. I need you to make a poster, I need you to put it up somewhere. I would suggest stick it on the front of your books. I would suggest put it somewhere prominent. You need to be confident with these. It is often where students fall down, and it's because they haven't really learnt them properly. They think they've learnt them, but they haven't quite grasped them. And just going through these extra ones at the bottom here, log to the base a of 1 over x. Well, that's the same as log to the base a of x to the minus 1, because that is the reciprocal, and we can write the reciprocal as x to the minus 1. Now, if we go back up here to this one here, if x is to the power k, we can multiply by that k the whole logarithmic function. So here, this is to the negative 1, that's my exponent, so I can just multiply by that negative 1, and it's subtract log a to the x or negative log a to the x, according where it would be within the question. This we've already used a lot of. Log a to the base a is 1, so that's getting at log 2 to the base 2 is 1, log 7 to the base 7 is 1, and that's really important to learn. And log 1 to the base a is always 0. If you're wondering what that's about, it's this format here, a to the 0 equals 1. So to rewrite that, it would be log 1 to the base a equals 0, because it's, remember, when we calculate the logarithm, we are finding the exponent there. Okay, so the exponent here is 0, so that's why that there is 0. So that links with your anything to the power 0 is 1. So pause, write those down, maybe at a later date, make a poster. They are very, very important. So we're now going to go on and we're going to do some examples. So here we have log of 6 to the base 3 plus log of 7 to the base 3. The bases are the same and they're adding, so we're using the multiplication rule. Now I would suggest that when you're doing these, that you have the rules on a separate sheet of paper so you can be looking at them whilst I'm going through them, because you need to be able to see these and go, yes, this is the rule we're using, the multiplication law, and that you can actually link that. So here I can say this is the same as log to the base 3 of 42, because that is using the multiplication rule. Okay, let's do the next one. B log to the base 2 of 15, subtract log to the base 2 of 3. Well, this rule I'm going to use is the division rule. So for the division rule, I'm going to write log to the base 2. Notice they're both the same bases, and it's 15 divided by 3. So it's going to be, let's just write it underneath, would be easier, log of 5 to the base 2. C. Here, 2 log 5, 2 log 3 to the base 5 plus 3 log 2 to the base 5. So first of all, how can I rewrite these? I can write I can rewrite this using the power rule. So it would be log 3 squared to the base 5. And what would this one be? Can you think what you'd write there? I'm hoping that you're gone for log, remember your base is 5, 2 cubed. There, okay. So this would then become log of 9 to the base 5 plus log of 8 to the base 5. And what rule would I use now? I've got an addition going on here. Well, because the bases are the same, I can put these together, and it's log of, and what do I do? Do I add them together and write 17, or do I multiply? I multiply because it's the multiplication law, and that's where people go wrong. So 9/8 are 72, so it's log of 72 to the base 5. So that question used 2 log rules, and if I'm honest, that's the more common thing I would expect to see. And the last one for this example set is D. And D, we've got the base is 10 this time, and we actually have a fraction going on as well. So this is going to use a number of skills. Now, first of all, with the fraction, there's a couple of ways you could go at this. And it's really up to you how you do it. And personally, I think I would get rid of the fraction first, but if you look at the example in the book, they don't. And the reason I'd get rid of the fraction in first is I know this is a reciprocal, so it's going to have a negative, which means that would go with that negative at the front and make it positive and would make my life easier. So I am going to show you two routes. So first of all, I could write log of 3 to the base 10, subtract 4 log and to the base 10 of 2. I'm just going to actually erase that because I don't need that bracket, of 2 to the minus 1, or 2 to the negative 1. And that would be the same as log of 3 to the base 10. Now that negative 1, because of the power rule, and this negative 4, we could do it a couple of ways. I might bring it down to start with to write that. You can do it all at once, but I just want to put extra stages in. And if you look, the negative 1 multiplied by the negative 4 would give me positive 4. But now that 4 is a power, so I could write it as like that, as 2 to the power 4. 2 to the power 4, I'm hoping you'll work out, is 16. Now, can you see, I would say, because of the funny pen that I'm writing with, my notation is getting all a bit muddled with this being a base, and this is a base, and this is here, and this is an exponent on the 2. Can you see, if I wasn't writing this clearly and I was getting a bit muddled with my lines, how it can go wrong? This is where it goes wrong. When I'm marking assessments and people getting a little bit of a pickle, it's because they're not clearly using their notation. So your notation's got to be spot on. And if you know you're not quite clear, this is your moment to step up, because this is where you'll lose marks. So then that becomes log and to the 10, and it's going to be 3 times 6, which is 16, which is 48. Okay, so that's one route. The other route, I'm not going to do all of it. I'm just going to show you. Let me write it in a different colour pen, actually, because it will make it easier for you to see. You could go for the log to the 10 of 3 and subtract, and you could put log to the 10 of a half to the power of 4. And a half to the power of 4, and remember you have got your calculator, so there's no need to be worried about doing that. You would end up with 1 over 16. And then the only difference here is, because you've got a subtraction, you would just have to remember that you're dividing here, okay? So you would do 3 divided by 1/16, and the answer comes out the same. So I like that one, but it doesn't make it better. This is equally as good. So we're going to move on now to the next example. I've just noticed, I think I wrote back up here, this was example 8, and it is an example 8. It's actually example 11, so let's get that corrected. So moving on, what we need to look at now, actually that wasn't example 11 I just did there, that was example 10. I'm now doing example 11. So example 11, A is log to the base A of x squared y z cubed. And what they want you to do is write this so that it's in the forms of log a to the x, log a to the y, and log a to the z. You wouldn't get a question like this in an exam, but this is trying to teach you manipulation skills. So these are all multiplying, so let's use that multiplicative law, and we have got log a x squared plus log of y to the base a plus log z cubed to the base a. And then because of the power law, we can go one step further, and it would be 2 log of x to the base a. This one would remain the same because there's no power involved, plus 3 log z to the base a. You'll notice I cross my z's. The reason is they get muddled and they look like 2's. That comes back to notation, and notation is really, really important that you don't get muddled between a 2 and a z. B. So next one, log. And this time we have 2 functions dividing. So if they're dividing, I'm using the division rule. So log of x to the base a, subtract log of y cubed to the base a. They're subtracting, and remember, I'm going to use my power rule again. Now, I would suggest that after each of these I've gone through, you pause the video, you write it down, you make sure you understand it before you move on to the next one. It's even worth you pausing, seeing if you can do them, and then going on to the next one. Okay, I'm going to do C and D. So C is the log, and we're using base A. And here we've got a bit of a division and a multiplication, and we need to get this in the right order. So first of all, I deal with the division, and you need to be aware of that. So first of all, I would write that. Subtract, remember, and my z. And then this bit here, I can split using the multiplication law, and I can write log a of x plus log a. And I'm going to write this as y to the half because I want it in terms of y. If you look at the answer, it doesn't want it in terms of root y. So I'm going to have to start putting it into an index notation rather than having it with the square root in. And that will allow me then to use the power law. So it would be x base a plus 1/2 log of y to base a minus log of z to the base a. So that is C. So that's C. Look at that. Look at how I went about it. First of all, that is done as a multiply, and that using the division is split up. And then when I go to this stage here, I have to go from my square root to a power or index notation, and then I use the power rule in the last part. And finally, D. And D is going to be log, and I'm going to be using that division rule, it looks like, again to me. So log of x to the base a minus log of a to the 4 to the base a. So here I can see that that's just log of that, but this, because of the power rule, some of you may already see straight away what this is going to end up being, and if you have, you don't really need to go through all these stages, but others of you won't quite see what this is yet. Now this bit here, log a to the base a, remember that's 1, and that's where they often people get a bit stuck in log rules and forget what they're all about, and therefore that is the final answer. don't miss that simplification out, because in a problem style question you're going to get to the end and you're going to find you can't get any further because you weren't seeing that simplification. So 4 examples done there on basic manipulation, and we're now going to go on to some solving, and this is where it's really used more. So going on to the next example from the book, we are asked to solve this equation, and it's about where do you start when you solve the equation. And what generally I would see is people will look and go, oh look, there's an add there, the bases are the same, I'm going to use the multiplication law. However, what they've forgotten to see is this 2 at the front, because that multiplication law isn't going to work when that 2 is at the front, and we have to think about the order that we use our rules in. So, and this is where, when I'm marking, I often go, oh, they've not quite got the order correct here, and the marks start getting lost because of the misconception. So the first thing to deal with here is that, okay? So I'm going to write down underneath log, and it's a 4 to the base 10, add log, and this is now going to be x squared, and that equals 2, because I've dealt with the number at the front, the number that's multiplying it, which is actually the power. Now I can go on and I can use the multiplication law, and I can write so, which is great, it's brilliant. Now how am I going to use my knowledge of logs to help me to solve the next stage? I'd pause and just think a moment. I'm hoping that you've remembered that what we're actually looking for here is that this base raised to this power, because remember this is the exponent. So this is my base, and the answer of log of 4x squared to the base 10 is the exponent, and so 10 squared must equal that. So I'm writing, and this links back to the previous section of work of how the different exponent form links with the logarithm. It's really key, that understanding and linking that together. Remember I discussed about it being the same as like square rooting and squaring and so on. So that's the same therefore as 4x squared equals 100. So x squared equals 25. And I'm going to pause here again, because the square root of 25, if I've got x squared equals 25, then it's very easy to say, well, x could be plus 5 or negative 5. And I imagine a number of you are thinking, yep, that's great. But I want to remind you about your graphs. And you can't have a negative value for a logarithm, and you need to think back, or a negative value of x, that's your logarithmic graph, that's 1, and can you see there aren't any x values back here that are negative, so you can't have x being negative. And again, that's what the examiner's checking, that you understand as well. So x equals 5 is your answer. Okay, well done. Let's do the next one. Okay, so here's the next one. Looks slightly more complicated, but it really isn't. We have here No numbers multiplying at the front, which is good because I don't need to worry about the power rule. And all I can see is a function and it's base 3, a function and it's base 3, and they're subtracting. So I can go straight for a division rule. So it's log of x add 11, all divided by x, subtract 5, base 3 equals 2. Then we come to removing our logs by writing it as an exponential. And remember that this is our base here. And so that's our base. And this is our exponent. So I then can write is equal to 3 squared. And from there, I could write that x add 11 is equal to 9, because 3 squared is 9, of x take 5. So x add 11 equals 9x. Subtract 45. And now, really, this is just a bit of very simple GCSE. So you should get 56 equals 8x. So x is equal to 7. And that's it done. Great. You really now need to get on with some practice, and there's loads of really good examples in exercise 14E of the Pearson textbook.